Last two problems involve work rate time problems. And we're going to look at a couple different ways to approach these. The first problem says Ed can paint the garage in 6 hours, while it takes Eddie 8 hours to paint the same garage. So we've got two different rates, right? Ed paints it faster; he can finish it in 6 hours. Eddie can finish it in 8 hours. So if they're working together efficiently, right? How long would it take them to get the job done together? One of the ways that you can approach this is you could say, look, Ed can do 1/6 of the job every single hour. And if I multiply that by how many hours he's working, right, that tells me, when he's going to get that one job done. It's just one, right? So if he works for just 1 hour, then he gets 1/6 of the job done. If he works for 2 hours, it's 2/3. If he works for 3 hours, he gets a half of the job done, right? So you can see as X increases, he's getting more and more of the job finished. What we're going to do is we're going to bring Eddie in. Eddie, right? He can do the job in 8 hours. So that means every single hour he can complete 1/8 of the job. Now, working together, right? Here's what we see is like this is now how much they're getting combined together each hour, right? We could just keep looking at. Now, what's the job? The job is to get one garage painted, right? So just one. So we're just wanting to see when these two numbers become the number one. Now, one way we can approach this now is I could just say I'm going to divide everything by X. It looks strange and maybe it's unorthodox, but I like looking at the problem this way because it helps me with like question 8. So if I divide both sides by X, I get the following. I get 1/6 plus 1/8 equals 1/X. So both sides, everything got completed everything was divided by X, and I get this new equation. Here's the thing I like about this view. X is literally how many hours it would take for them to do the one job working alone, right? Now, if I look at, before we solve that problem, if I look at the problem below it with Juanita, she can complete a beginning level Sudoku in 24 minutes. Darnell has never tried a Sudoku, but he's willing to work with Juanita. And together it takes them 14.4 minutes. So here's what's cool about this. I can represent how much of a person can do. They can do 1/24 of the thing, the 1/24 of a Sudoku per minute. This other person, I don't know, right? But they can do 1/X of the job per minute. And working together, right, they can do it in 1/14.4 minutes. So this thing that I've written down right here is kind of inspired by this view that I had up above. So let's go ahead and solve the top one for Ed and Eddie, but there's not an extra Ed. If I wanted to clear the fractions here, I could multiply both sides by 6 times 8 is 48. But I think I can actually get away with just multiplying everything by 24 because 24. Because I think 3 times 8 is 24 and 6 times 4 is 24. So I'm going to go through and I'm going to hit both sides of that equation with a factor of 24. In the first case, it's going to give me 24 divided by 6 is 4. So I'm going to get 4. I'm going to have to hit everything with an X because there's an X in the denominator. I'm going to multiply by 24X. Oh, I'm glad I caught that now. So when I divide 24 times X by 6, I get just 4. So this is going to become 4X plus, same thing on the other side, I'm going to multiply by 24/X. 24/8 is going to give me 3. So this is plus 3X, and that's just going to equal the number 24. So 24. So 7X is 24. Therefore, X is 24/7. And if I express that as a decimal, I've got 3.43. But I got X is 3.43 hours, right? Be careful. That's not 3 hours and 43 minutes. That's 3 hours and 43 hundredths of an hour. So 3.43 hours is how long it would take together. So the answer is 3.43 hours. Okay, next problem. Same exact thing going on, except this time, what is 24 times 14.4? Ugh. I don't think I want to multiply. I don't like this 0.4. I have to be careful, right? This is not a ratio. I can't flip everything. This plus would really that's not something that's true. Pick a couple numbers and convince yourself that you can't just take the reciprocal of both sides when you've got this plus here. That's not an option. If I multiply 24 times 14.4, I get 345.6. I'm not really impressed with that. What happens if I multiply everything by x? I would get x over 24 plus the number 1 equals x over 14.4. Okay. Don't know where I'm going with that. Trying to solve for x. I'm going to subtract x over 24 from both sides. So I get the following. I get 1 is going to equal x over 14.4 minus x over 24. All right, I want to combine those, but they're not the same denominator. And unfortunately, I don't like that this is. Let me do this. I'm going to multiply x over 14.4. I'm going to by a giant 1, right? So I'm going to write this as 1 is equal to 10x over 144. Why does that help my brain so much? 10x, and then minus x over 24. So if I look at 24 and 144, I think 12 squared is 144, right? Yes, it is. So that 144 is, if I think about its prime factorization, it's 2 times 3 times a 2 times a 3, right? No, that's more than that. It's 12 times, it's just 12 times 12. It's just 12 times 12. And the 24 is a 2 times a 12. So I think I can multiply. What is 144 divided by 24? Is that nice? Oh, yeah. Geez. I'm just going to multiply both sides by 144. So if I do that, right, hit both sides with 144. I didn't realize that 144 was divisible by 24. If I do that, I get a lot cleaner looking equation, right? I get 144 is equal to 10x minus 6x. Oh my gosh, that's so much more beautiful. I love that. Therefore, right, 144 is equal to 4x, and 144 divided by 4 is going to give me the number, what? 144 divided by 4 is going to give me the number 36. So apparently x is 36. Now, I've been all over the place with this. I'm thinking that it would take Danielle 36 minutes, minutes, to solve this. But before I'm going to be happy with that, I am definitely going to come in here right now, and I'm going to plug in x is 36. So on my calculator, I'm going 1 over 24, and I'm going to add to that 1 over 36. It's going to turn that into a fraction for me. If I turn that into a decimal and then take the reciprocal, I get the number 14.4. Yes, that definitely is a solution. So it would take Darnell 36 minutes to complete the Sudoku. So hey, take some time looking at these, thinking about these steps. right? How do you write it out? How do you structure this? I think this is probably like one of the biggest insights right here, starting with this, right? And then, actually when I when I look at this, I can see this problem kind of landed at the same spot, right? You can see that right there in a way. Actually, exactly that's what that is. The one is the job together. So, yeah, that's it. Have a look at these. Talk to me in class if there's anything you'd like to discuss further, and I'll talk to you later.